Hey there, you rates, Mr. Herman here, and this is exercise 5G, expanding brackets. We made a bit of a skip from exercise 5D straight to 5G. Learning goals for this lesson is to understand that the distributive law can be used to expand brackets. And the success criteria is to be able to expand brackets using the distributive law and to be able to use expansion together with combining like terms to simplify expressions. Now, expanding brackets, it's one of those topics where you find it, you look at it, you find it quite tricky. You don't understand what you're doing, or it's really simple because just a set of 2 rules that you have to consider, or sometimes 3 rules that you have to consider, and you can just go ahead and simplify something. So I don't want to teach you the rules straight away without showing you the notion behind what it actually is and why it works. So expanding brackets, there's this thing called the distributive law, and distributive just means to distribute out. When you distribute out, you give out a certain amount equally, you distribute out. So say for instance, if we were to go back into class and I had 20 students and I had 40 cupcakes, each student will get obviously 2 cupcakes. I would be distributing out the cupcakes equally, or to whatever amount I have, to each student. So it'll be 2 for one student, 2 for 2, etc., until all students have cupcakes. So to distribute means to give out proportionally, or to give out equally. Now there's this rule here that says that when you have a term A and this is being multiplied with 2 terms that are being added together within brackets, say B and C, this means that we're going to get A and multiply it by B, and we're going to add A and multiply it with C. Okay, and what this would equate to is just AB plus AC. Now, at any point, the questions that you will get within the textbook can either have numbers associated with letters, just letters, most of them are numbers, and maybe just one letter. You won't get all of these being numbers, because if you can actually just work this out to get a number itself. So there will be elements of either 1, 2, or in this case, even 3 letters within there. Okay. If you're looking at this, okay, this is just a rule. If you're looking at this and saying, what is it and why, that's okay. All right, I'll show you the notion just in a second. The other distributive law is when you have A being multiplied with B take away C, and the B take away C is within the bracket, it's still A times B, but then we are minusing because of this minus sign, and then doing A times C. Okay, and you got to be careful where there is a takeaway or a negative sign. It could be there, or it could be 1 there. We'll look into that in a few other examples. But for now, where does this law come from? So say for instance, I had 20 circles. All right? I'm quickly going to draw 20 circles of some sort. But I'm going to draw it in the notion of 5 down. So 1, 2, 3, 4, 5, and 4 across. So all up, we have 20 circles, 4, 8, 12, 16, 20. So you can count them by 4s or count them by 5s. This will equate to 20. And just to show you how many are going down, this is 5 lots, and this here is 4 lots. Now, when you're in primary school, when you're first learning the concept of multiplication, you look into arraying numbers in a nice little format like this, because all multiplication is just repeated addition. So 5 times 4 is just the same as doing 5 plus 5 plus 5 plus 5. You're doing 5 pluses 4 times. Or you can do it the other way around. You're doing 4 lots 5 times. 4 plus 4 plus 4 plus 4 plus 4. So multiplication is just repeated addition, or repeated groups of addition. But we do it, we try to get you guys to memorize times table, so that way working out repeated additions is much simpler. So we have here 5 times 4, and this is equal to 20. And if you haven't realized it, this is the same concept of area and how to work out area of a rectangle. But instead of circles, you're working out squares. Same concept there. Now, what I'm going to do is, instead of writing 5 times 4 is equal to 20, I'm actually going to get a split line. And I'm going to draw this in a different color. I'm going to make this green. So I'm going to get a split line, and I'm going to split it. And I can split it anywhere vertically in between the dots. Let's put it down here. Okay, so I'll put this split line. So what I'm going to do is I'm going to redraw this set of 20 dots, but I'm going to kind of separate them. I'm going to put 5 here, and I'm going to put the other 3 here, and we still have 20. We've just split them up into 2 different parts, 5 by itself and 15 by itself. So what we have here is we've still got 5 going down right here, but right here we've just got 1 going across. There's just only 1 group of 5. Here we have 5 going down, but we have 3 groups that go across. Now we still have 20. Okay, we still have 20. So what I'm doing is I'm getting 5 lots of 1 here plus 3 here. Yeah. So because I can put this 1 plus 3 within a bracket, it's still going to give me 4. We know there are 4 lots. We've just split them up into 2 different parts. 1 here and 3 here. And how many do we have here? We have got 5 lots here and 15 lots here. So this is where this expansion rule comes from, or the distributive rule comes from. I've got 5 lots of 1 within this group, and I'm gonna then add 5 lots of 3, which is here. I'm distributing that 5 to however many groups that I want. And this 1 plus 3, I can write that as 1 plus 3. I can write that as 2 plus 2. I can write that as 1 plus 1 plus 1 plus 1. It depends on how many times or how many different types of groupings you have and how many lots are within those groups. In this case, I've got 2 groupings. One of them is just 1 and the other one is 3. So I'm getting 5 lots of 1 and 5 lots of 3. And I know what 5 times 1 is. This is 5. I know what 5 times 3 is. This is 15. I wrote them down here, and 5 plus 15 is going to give me 20, which is essentially what we had to begin with. Okay, so what I've done is I'm distributing out in different ways, and this is what we're going to implement, but we're going to mix algebra with this as well. So we're going to have letters that are involved, because we might have a certain area of some sort, like so. And this could be split up into 2 parts. We can have 3 as the length going down. We could have 4 that goes across here. And then we could have this unknown number that we don't know, which is, say, the letter T, Taz. Always like using the letter T. We know what this area will be here. This is 3 times 4, which will give me 12. But we don't know what this length is, and therefore we don't know what the area is. We know it's going to be 3 times whatever this t length is. So this is 3 times t, which is 3t. This is the concept of expanding brackets. So what this ends up being is 3 times 4 plus t, which is just 12 plus 3t. 12 plus the 3t, if we were to focus it on area. So let's tackle a few examples. Hopefully this concept makes sense. If you're still looking at this and you're saying, "Ooh, this is confusing," after a few examples, you will get the hang of it, because we're just applying 2, sometimes 3 different laws, depending if there's a negative in front of the number outside of the bracket. Okay, so with the first 3 examples, we're going to use the distributive law to expand the following questions or expressions here. So this is how you lay this out. I always like to write out the question out like this, and then with a different color, I start at the term that's outside of the bracket and I draw an arrow to it being within the first term inside the bracket. This is to indicate that that 3 is going to be distributed to 2x, and the 3 is also going to be distributed, so I draw another arrow from the 3, and I draw an arrow distributing out to the 5. So there's 2 terms that we are distributing out to, a 2x and a 5. Now I don't know what x is. X could be some number we don't know, but what we can do is expand this out. We're going to get 3 lots of 2x, so this is 3 times 2x, and we're going to add, because there's an add in the middle, 3 lots of 5. Now if you want to underline these just to show that that's an equal sign, sorry, just to show that there's 2 lots of grouping in this, you can, to make it easier to read. And we're going to simplify this as much as we can. 3 times 2 times x, we just focus on the number part. That's just 3 times 2, which is 6. With a little x tagging on. So we have 6x here, and 3 times 5, which is 15. And that's all we can do. That's as much as we can do for this, this just distributing out. So we're distributing that 3 to both the 2x and the 5. What we'll be left with is 6x plus 15. As long as you know these concepts or these basic rules and you're fine with your multiplication, and again, you can use your calculator to help you out, you should be fine in tackling these type of questions. B. With B, we're going to have -8 multiplied by 7 plus 2y. Now you got to be careful because there's this pesky little negative sign in front. So let's draw our arrows. 8 can distribute to the 7. -8, sorry. -8 can distribute to the 7. And -8 can distribute to the 2y. Now you've got to be careful with your negatives and your multiplication. Remember, a negative times a negative will give me a positive. And negative times a positive will give me a negative. And a positive times a negative will give me a negative as well. So this right here is a negative number times a positive number. So let's write this out. This is -8 times 7 plus -8. Put these in small brackets just to indicate that it's a -8. So -8 times 2y. All right, -8 times 7. So this will end up being 56, but it's a negative times a positive. So it's a -56, so just be careful. And we're adding -8 times 2y. This will give me -16y. -16y. Now we have a plus and a minus together. If you remember from your negative and positive rules, if there's a positive and a negative put together, this will give me a negative. So we end up with -56. Take away 16y. And that there is our final solution for this. So be careful with your negatives. They can be a bit tricky. Right? As long as you know to distribute this out accordingly, you should be fine. Just be careful of your negatives. Last one is we've got C, 4x, and it's being distributed out to 2 -y. So 4x, 2 minus y. Draw our arrows to just show that this 4x is being distributed to the 2 and the -y. There's a -y here, so you got to be careful. So this is a 4x times 2, and this is being added to 4x times -y. Right, so just be careful of that. And this is where that first rule, this is why it turns into a negative. You'll see y will always be a negative there. So let's have a look. 4x times 2 is 8x. Pretty simple. And 4x times -y, so a positive times a negative will give me a negative 4xy. There's no number component, so we just leave it as 4xy. Aha, we have a plus and a minus. Plus minus is going to give me a minus, so it has to be a minus no matter what. That's why in the rule, it will always be a minus there when you do the distribution. So what we're left with is 8x minus 4xy. And that will be the final solution for that. Now, the next skill we're going to be looking into is expanding out and then also collecting like terms after you've done the expansion. So there's going to be a bit of multitasking involved with this one. Let's first have a look at this type of question here. We want to simplify this, or expand this out first and then simplify afterwards. So we have this distribution that we have to do, and then we have this plus 3b that tags along. So let's draw our arrow. The 3b will be distributed to the 2b, and will also be distributed to the 5, but it won't be distributed to the 3b because the 3b is not within the bracket. The 3b is that annoying cousin or sibling that you have at a social gathering of some sort that just tags along. Yeah, way to put some relevance of algebra into real life. Okay, so this one here, this will be 3 times 2b, which is 6b, and 3 times 5, which is 15. So see, I haven't wrote the expanded version out. I've just gone straight into it. 3 times 2b I know is 6b, and 3 times 5 I know is 15. All of them are positive, so we've got a plus here. I don't have to deal with pesky negatives. And then we have that 3b just tagging along. Now we have 6b plus 15 plus 3b. Now we've got to remember, we can collect like terms. A like term is if there is a letter that is the same within this expression, they are like terms. They like each other. 6b and 3b are like terms because they have the b in common. So 6b plus 3b, we have 9 lots of b plus 15. So this plus 3b changes this because it's being added to the expanded version of this here, where the 6b plus 15 comes from. So we're adding that 3b afterwards to get a 9b plus 15. So make sure that when you see a question that looks like this, that you also do the addition or subtraction of whatever the like term is. Now, last example before you guys tackle your questions, we have 12xy plus 7x distributed to 2 minus y, the 2 minus y within the bracket. So that 7x is going to be distributed to the 2, and the 7x is going to be distributed to the negative y. I put my arrows just underneath. Same concept. It's still indicating that you're distributing now. So it doesn't matter if it's on the bottom or the top. You can even have one top, one bottom. It doesn't matter. You just want to indicate that that 7x is going to be distributed to the 2 terms within the bracket. So we still have this 12xy, that's at the start. 7x, or positive 7x times positive 2 will give me 14x, which is a positive. And positive 7x times negative y, a positive times a negative will give me a negative, and we'll be left with just 7xy. All right, now we've got to look for the like terms. So which one of these, pretty much the odd one, is the odd one out. 14x is the odd one out because we have a 12xy here and a negative 7xy here. The x, y are the like terms. They like each other because the terms are the same. And if this was 12xy and this was negative 7yx, it will still be like terms because the ordering of the letters makes no difference. So 12xy, take away 7xy, we'll be left with just 5 lots of xy's. And then we have this 14x at the start. Oh, at the end rather, at the end. And that there cannot be simplified any further down because there's no more like terms. That will be our final solution. So the questions that you need to tackle for exercise 5G, which is page 318. Remember, this textbook can be found within the resources tab within Compass. When you look into exercise 5G, we're going to be attempting the following questions. Question 1, question 2, to left-hand side, question 3, to left-hand side, and question 4, to left-hand side. So just questions 1 to 4, or the first half of each questions. If you need any help, you know where I am, Microsoft Teams. Best of luck, guys, with this exercise. I know this one is quite a tricky one. We've got one more exercise after this. I'm not too sure if I'm going to be teaching this remotely or if I'm going to be teaching this in class. And then after that, we'll have a revision session and then we'll attempt our CAT for this test. The CAT won't be on essential assessment. The essential assessment is just a tool to help us with some of the textbooks that work and just to break up the monotony of the textbook questions that you were always doing in class. Okay, so the pretest was used just to determine how you guys went. So for now, stick to this exercise. We've got one more exercise next week. We're going to be in a bit of a rush, so we're squeezing out as much as we can. But until then, I'll see you guys within the next lesson, whether that be face to face or remotely. Have fun. Take care, guys. See you soon.